Hey guys and girls, this is a little support video for week 6. Before you work on lesson 1, this is just a little review on square roots and finding square roots in general. Okay, so let's take a look. So we know that the area of a square with a side length of 12 units is 12 squared, or 144 units squared. We know the area of a square, of course, is the side length times the side length, or length times width, in which case the side length is the same. So that would be 12 times 12, or 144 square units. Now, if the side length of a square, the side length of a square with area 900 square units, or units squared, is 30 units, because 30 squared equals 900. All right, so if it has an area of 900, we're looking for what number must we square to get 900. That number is called the square root of 900. Sometimes we want to find the area of a square, but we don't know the side length. For example, how can we find the area of square ABCD, here shown in the picture? So one way we can do that is to enclose it in a square whose side lengths we do know. So let's take a look at what that process would look like. So I've enclosed ABCD in a larger square, EFGH. Now notice that the side lengths of EFGH are 11 units. That means that the area of EFGH, the large square, is 11 times 11, or 11 squared, which equals 121 square units. So the large square is 121 square units. There are 121 of these squares inside of the large square, including the blue region, ABCD. So the area of each of the 4 triangles on the outside here, they would be 12, because we have a length and width of, or a base and height of 3 by 8, and the area of a triangle is 1/2 base times height. So 3 times 8 would be 24. Half of that would be 12. So there's 1, 2, 3, 4 triangles with an area of 12. Well, then we could take that area, 48 square units for the triangles, and simply subtract it from the 121 from the large square, and what will be left over would be the blue region. So that gives us 121 minus 48 equals 73. The area of the blue region would be 73, or 73 square units. Okay, so we know this square has an area of 73 square units. Well then, what's the side length? Well, we know the area of the square is between 8 squared, which would be 64, and 9 squared, which was 81. So if we had perfect squares with those side lengths, they would yield areas of 64 and 81. So the side length, then, it reasons, must be between 8 units and 9 units, because 73 is between 64 and 81. So we can also use tracing paper if we wanted to trace a side length, and we can compare it to the grid, which also shows the side length is between 8 and 9 units. But we want to be able to talk about its exact length. So in order to write the side length of a square whose area is 73 square units, we use the square root symbol. The square root of 73 is written here using what we call a radical symbol, a radical sign, with a 73 underneath it. Kind of looks like a division symbol. And it means the length of a side of a square whose area is 73 square units. So if there's 73 square units inside, each side length must be the square root of 73. And here's just another visual of finding the area of a square. If we have a square with an area of 9, there's 9 square units inside of it, then its side length must be the number which you squared to get 9. That would be 3. So 3 is said to be the square root of 9. Likewise, if we have an area of a square that's 16, then the side length would be the number you squared to get 16. So the square root of 16 would be 4. Now, if we have an area of a square that's 10, that means we should reason that the square root of 10, or the side length of the square, should be somewhere between 3 and 4, because the area itself, 10, is between 9 and 16. We can say the area of this the square root of 10 should be the square root of 10, or we can say that it's somewhere between 3 and 4. We could maybe estimate 3.1, 3.2. to give an estimation of that square root, because 10 is close to 9. So I would expect this square root to be just a little bit more than 3. But the precise value will be the square root of 10. We say the side length of a square with the area 73 units squared is the square root of 73 units. This means that the square root of 73 squared equals 73. If you square the square root of a number, it's going to give you the number itself. So all of these statements are also true. So the square root of 9 is 3 because 3 squared is 9. The square root of 16 is 4 because 4 squared is 16. The square root of 10 units is the side length of a square whose area is 10 units squared. So the square root of 10 squared would equal 10. So in short, the square root is a positive number n. The square root of a positive number n is the positive number whose square is n. It is also the side length of a square whose area is n. We write the square root of n as, using the radical sign, the square root of n. For example, the square root of 16, written as the square root of 16, is 4 because 4 squared is 16. 16, the square root of 16, is also the side length of a square that has an area of 16. I will also include a link to this video from a different Mr. Morgan explaining how we can find the side lengths in 6.2 in slides 5 through 9. So you can play the video that shows you how you can use what you know to find the side length of a triangle in Activity 2. So this should be helpful as well. So look for that link. All right, guys, I hope this helped a little bit. Just a little reminder, refresher of square roots, and good luck on your final week of lessons for your summer course. Good luck.